Hi, hello. So today we are going to discuss an interesting sum from differential calculus and curve sketching. And as you can see, the question states over here that you are expected to find the equation of the tangent and the normal to the curve x implies x plus 1 upon x, where x is not equal to 0 at the point 1, 2. And what are you expected to find over here? Over here you are expected to find the equation of tangent and equation of normal. This is the very first part of the question. Let me remind you, they have told you to find equation of tangent and equation of normal to the equation x, where x implies to x plus 1 over x, x not equals to 0 at the point 1, 2. Okay, then there's a second part of the question also, where they're asking you to find the coordinates of the point where the tangent and the normal, both the lines, are crossing the x and the y axis. Okay, so the second part, they are asking you to find the coordinates of the point where tangent and normal crosses both the coordinate axis, that is, they cross the x-axis and the y-axis. Okay, so that's the second part that they're asking you in this question. And the third part, they're asking you, once you identify what is the equation of the tangent, what is the equation of the normal, right, and you will know these coordinates of these points, you are expected to find the area enclosed by the x-axis. So this is, I'll name it as C part. The final part of this question, you are expected to find the area enclosed, right, by x-axis, y-axis, the tangent and the normal. So there goes our entire question, which is, I've divided into 4 different parts. Always remember, when you do math, you have to first, as soon as the sum comes in front of you, do a first time reading and then break the sum so that you can understand the concepts behind the sum and then apply the appropriate applications in it. Okay, now here, since we are supposed to find the equation of tangent, equation of normal, okay, we will be discussing what concepts are we going to use in this particular sum. Okay, so the very first concept that I am aiming at over here in this sum is to know how to derive a particular equation, how to find the first derivative. So the first derivative, which you are already aware of pretty well, that if they have given you y is equal to x to the power of n, and if I am supposed to differentiate this particular component with respect to x, so dy by dx is given by nx to the power of n minus 1. Okay, in other words, I can also represent this y as function of x, that's f of x is equal to x to the power of n. So dy by dx, that can be represented as, using this notation, f dash of x is equal to nx to the power of n minus 1. Note here, y or function of x, dy by dx or f dash of x are one and the same thing, no difference. They are just 2 different notations to denote these respective functions. Okay, that's the first principle that I am going to consider using in this sum, and I'll show you where we'll be using this particular principle. Secondly, we are supposed to find the equation of a line, and since we are expected to find the equation of line, you know that it can be found out using 2 different equations. Firstly, I can use a simple equation, y is equal to mx plus c. Am I right? So where I know that this c stands for y-intercept. Y-intercept is the point where my equation of the line, my graph will cut the y-axis or cross the y-axis, and m is nothing but my gradient or slope. Okay, so now that is the very first equation. But now here we've got the equation x is equal to x plus 1 over x at the point 1, 2. So we don't have the slope, we don't have the gradient, that is, and we don't have the y-intercept as well. So that means this particular equation we won't be able to use in order to find the equation of the tangent or the normal. So let's go to the second equation, which states y minus y1 is equal to m into x minus x1. So that's a base that I am trying to revise through so that you can remember exactly what we are aiming at over here. So in this particular equation, m as it is stands for gradient, or you can call it as slope, and your y1 and x1 are the coordinates or the points through which your equation or line is passing through. As they have given you, x plus 1 over x passes through the point 1 comma 2. So that coordinate is given to you. What you are expected to find over here is only the gradient. Okay, so that's the second concept we'll be using in order to determine the equation of a tangent. Once we know the equation of a tangent, how do we determine the equation of a normal? For that, you need to know what is a tangent and what is a normal. And I hope you are well aware of what is a tangent and normal and what's the relation between the tangent and the normal. So say if I take any equation, a particular graph of that equation, and I take a point over here and draw a tangent passing through that point. So you know what is a tangent. Tangent is a line which passes through one point on the curve. Okay, so let me name it as A, B passing through point C. So this is nothing but my tangent, and any line which is passing through this point of intersection of the tangent and the curve and is perpendicular to the tangent is called as the normal. Any line. So we know that what is the relation between tangent and normal. A tangent is always perpendicular to normal, or vice versa. A normal is always perpendicular to tangent. So tangent and normal are perpendicular to each other. These two lines are always perpendicular to each other. And now, since these two lines are always perpendicular to each other, the fourth concept that we are going to use in order to determine the equation of the normal in this sum is nothing but your slope relation. So two given lines, if they are parallel to each other, right? That is, if they are parallel to each other, then what is the relation between their slopes? Gradient. The gradient will always be equal, because anyway you draw the lines this way or any other direction, the gradient, the steepness of the slope is going to be same. So m1 is always equal to m2. But when these two given lines are perpendicular to each other, when they are perpendicular to each other, you can observe that the relation between their gradients is m1 m2 is equal to minus 1. Okay, so these are the four concepts that we are going to touch upon while solving this particular sum. The equation is given to us very well, how we are expected to find the equation of the tangent. Alright, so here goes the solution. We have our equation. I'll write it down as function of x is equal to x plus 1 over x, and I know in order to find the gradient I need to find out the derivative of this particular equation, right? So let me make it simpler to find out the derivative. I'll write it down as x plus x to the power of minus 1. 1 over x can be written as x to the power of minus 1. So therefore that will imply my function of x, f dash of x, derivative would be derivative of x to the power of 1 would be 1x to the power of 1 minus 1, right? Plus derivative of x to the power of minus 1 would be minus 1 x to the power of minus 1 minus 1. We are using the very first principle over here of y is equal to x to the power of n, which I already showed you that y is equal to x to the power of n is nx to the power of n minus 1. So therefore I can very well say that f dash of x to the power of 1 would be 1x to the power of 1 minus 1, and x to the power of minus 1 would be minus 1 into x to the power of minus 1 minus 1. On solving this, I get 1x to the power of 0 minus 1 x to the power of minus 2. In other words, I can say x to the power of 0 is nothing but 1 minus 1. This x to the power of minus 2, I'll make it positive, take it in the denominator. So that's my derivative of x, which I have already found out. Now since I need to find out the gradient at point 1 comma 2, so I'll find out f dash of 1 will be equal to 1 minus 1 over 1 square, right? That is going to give me equals to 0, and f dash of 1 is nothing but my gradient for the tangent. So gradient for the tangent is 0. That is very, very clear. So now we have the gradient for the tangent, this is at the point 1 comma 2, which I can take as x1 y1. I have the gradient, I have the coordinates. I can very well find out the equation of the tangent, which is given by the equation y minus y1 is equal to mt, which is gradient of the slope, into x minus x1. So I have y minus my y1 is 2 is equal to gradient is 0 into x minus x1, that's 1. So I get my equation of the tangent is nothing but y is equal to 2. So this becomes my equation of tangent. I hope this is very, very clear. So now let's find out the second part. That's my A part, which I have found out. That is, what is the equation of the tangent. Now I need to find out the equation of the normal, correct? And I know which principle I'm going to use, that when two lines are perpendicular to each other, their gradients, product of their gradients is equal to -1, right? So now here I'm going to use that mt, that's gradient of tangent, into mn, gradient of normal, will be equal to -1. Okay, that implies my mt is nothing but 0 into gradient of normal is equal to -1. So I'll write my mn is equal to -1 over 0. My goodness. So here we are getting a 0 in the denominator. In other words, if I want to solve further, I can write that the gradient of this normal is nothing but infinity. Okay, because it's not defined when you have 0 in the denominator. So now what we are going to do, we'll be leaving this gradient over here only as it is, because as such this is not what we are expected to find. We are expected to find the equation of the normal. Okay, now let's find the equation of the normal. Again, we are going to use the second equation, which is y minus y1 is equal to mn into x minus x1, and I know that my both tangent and normal are passing through this point only. Let me mark it with red so that you can know. Both tangent and normal are passing through the point 1 comma 2. Okay, so my x1 y1 remains same. Now here y minus y1, that is 2, is equal to gradient of normal is -1 over 0. Okay, now you understand why I am taking it as -1 over 0 and not as infinity, because if I take it as infinity I won't be able to find out the right equation of the normal. Okay, and x1 is nothing but 1. I shift the 0 into y minus 2 is equal to -1 into x minus 1, correct? That gives me my equation of the normal as x equals to 1. So this becomes my equation of normal. So now you can say that I have got my equation of the tangent and I have also got my equation of normal. That completes the first part of the sum. The second part of the sum states that you are expected to find the coordinates of the point where the tangent and normal crosses x-axis and y-axis. You are expected to find the coordinates of the point where your tangent and normal is crossing the x-axis and y-axis. Okay, so let's just draw roughly where these two equations are crossing. Okay, so now I'll just write it for your reference. Our equation of tangent that we got was y is equal to 2. That's my equation of tangent, and the equation of normal that I got is nothing but x is equal to 1. Okay, let us take a coordinate axis over here, right? So I'll just take a coordinate axis. Please excuse me, I'm not using any stencils over here. So these are my coordinate axis. This is my x-axis and this is my y-axis. Okay, that's the origin. Now where will this equation y equals to 2 be? Let me number them as, I'm taking one unit as 1 centimeter right now because the equations are quite smaller ones. Okay, so there goes my coordinates of y-axis, and here the negative. Okay, so now where am I going to have my y equals to 2? So anywhere on this line y equals to 2 will be a line horizontal to the x-axis, parallel to the x-axis, sorry, okay, not perpendicular. So anywhere on this line my y equals to 2, this is the graph for y equals to 2, where will be my x equals to 1. So I can have my x equals to 1 is this graph, x is equal to 1, line parallel to y-axis and perpendicular to x-axis. Okay, now in what is my third part? They have asked me to find the coordinates of the point where the tangent, this is your tangent, right? So let me write it. This is your yt tangent and this is your normal. Okay, so you are expected to find the coordinate of the point where the tangent is crossing the x and the y-axis. Now this tangent is not going to cross the x-axis, definitely it will be crossing the y-axis, correct? So I'll be writing that coordinate of point, let me name it as A, B, C and O. This is already origin. Coordinate of point A, this is where my tangent is passing, is nothing but 0, 2, right? So this is nothing but where tangent passes the y-axis. And similarly, coordinate of point C, that is this coordinate, would be 1, 0, where normal passes the x-axis. So that completes my third part of the question. And finally, the question is asking, find the area enclosed. Find the area enclosed by the x-axis, the y-axis, the tangent and the normal. And from the figure it's very clear that this is the area which is enclosed by the x-axis, y-axis, the tangent and the normal, and I'm expected to find out the area of this particular figure, which is very, very simple. So I can write my last part of the question, that area enclosed is nothing but, this is kind of rectangle, right? So we know that this is how much. Here I have this as 1 unit, which I can take it as length, and I can see very well from the graph this is nothing but 2 units. So the area enclosed would be length into breadth, that is equal to 1 into 2. So my area is nothing but 2 square units. So that's how simple the question is. When you break it into parts and try to understand it, I can understand I was a bit slow in explaining, but then this is required so that you can understand the concepts used in this particular sum which we have applied already, and how do we go about in breaking the sum and doing it. Generally in exam, if you try to do this sum, you should not take more than 3 minutes to solve this particular sum. So keep watching KT Educare and subscribe to our YouTube channel so that you can keep on getting more and more video lectures on the subjects of your choice and the lectures of your choice. Thank you. Have a great day.